Hello. This is my video about frequency tables, really grouped frequency tables and histograms, and what they are and how to make them focusing on Excel. Of course, you could do them by hand, and that's with a small data set, it's actually not very hard to do it by hand. So hopefully after watching this video, if you don't want to use Excel, you will be able to do it by hand also. Okay. Okay, so let's see. I am going to share my screen. And the first thing I want to talk about is, hold on, I can't seem to talk and share my screen at the same time. Um, just real quick, want to talk about the difference between a histogram and a bar chart. Um, so, and I also want to point out, right, there's a difference between like what things are sort of, like theoretically and definitions and things and versus like what we do when we use technology, because you'll see that when I make a histogram in Excel, I actually don't use the histogram function because it doesn't work right? So you'll see that I actually use a bar chart. It ends up being the exact same thing, but it seems to work just a little bit better because I'm not sure. I've had a really hard time using the histogram feature on Excel. So I use bar charts. However, theoretically, there's a difference between bar charts and histograms, right? As you can see here. Let me make it bigger, just a little bit bigger. For those of you on mobile devices where the screens are so tiny. Okay. And if you wonder why I keep looking down here, I'm actually on two screens. One is right in front of me down here, and one is right here. Okay. So main differences, right? Well, main similarities is they're both made of bars, right? You can see that they have these little rectangles that go up. Frequency is the vertical on the vertical axis in both of them. So like if we were to label this, right, this is going to be frequency for both graphs, right? Meaning that the height of the bar is telling you how many data values are in that range or in that category. Right, so typically bar charts are used for categorical data, right? You can see in this example, like January, February, March, those are not numerical values, right? Say I'm asking like, what month were you born? You're going to say February, right? Versus like, how tall are you? And you'd say like 5'4". So, uh, we're reading, I think this week, a little bit about the difference, right, between categorical and numerical data, right? So typically, conventionally, bar charts are used for categories and histograms are used for measured things. So no things that occur on a naturally occurring scale. Now, of course, right, I can build a bar chart. If I just make the bars super wide so that they touch, you basically have a histogram. So you'll see like what I said before about using Excel. But, technically there is a difference between histograms and bar charts. Histograms have numerical data, right? No gaps in between. Bar charts have categorical data. I mean, you have like gaps, like there's nothing on the edge between January and February. You can't be both, right? You're either January or February. Where if you look at this histogram on the left here, right, you might notice that this bar, these two bars both share, like they both have an edge on the 8. So that can be a little confusing. You're like, well, are you counting all the people that, I don't know, say this were what we're measuring, counting oranges or something, right? Like, well, if I had 8, am I in this category or am I in this category? And that actually can be an issue. Oftentimes, well, I'm trying to erase. There's some conventions about that. Right, where usually it's like people say it actually doesn't have to be this way, but it's always in the left bar or it's always in the right bar. You got to tell people what you mean. I actually am going to do it in such a way that you don't have to worry about that. You don't have to say which bar the data in that range is, because we'll take care of that by using specific values on the axis. Okay. Okay, so technically that's the difference between a bar chart and a histogram. All right, let's do a little bit of vocab on the histogram. So each of these bars represents a class, right? And the class is really just an interval of numbers. So you see like this bar goes from 4 to 8. What is going on? My toolbar is not acting right. That's what I wanted. Okay. This bar goes from 8 to 10. This bar goes from 12 to 16, right? This one goes from 16 to 18. So you see that each of those, there's a little range of values that each bar covers, right? So that range is often called the class width. So the width of the bar, what the range of one particular bar is often called the class width. And that's what we're calling it, right? So each of these bars has the same width. So the class width, in this case, if you look at this one, what is it? They're each 4. 4 to 8 is 4, 8 to 12 is 4. Yeah, so the class width is 4 in this particular histogram, right? Typically, histograms have bars that are all the same width. Technically, you don't have to, but typically they do. So that's the class width. Whoa, I forget that I can't erase that way when I'm doing it this way. Okay, so class width is 4. The numbers at the beginning and end of each class are called the class limits. So for this first bar, the lower class limit is 4 and the upper class limit is 8. For the second bar, this one, the lower class limit is 8 and the upper class limit is 12, right? So those are words that I'm going to be using: lower class limit, upper class limit. And then we have class width. We have number of classes, right? And the number of classes is just the number of bars. So we've got 1, 2, 3, 4, 5. So we've got 5 rectangles. We have 5 classes. So all the data is divided up into 5 groups, right? Where one group is all the values between 4 and 8, and the other group is all the values between 8 and 12. Okay. All right. I think that's enough basic information that we can move on. Okay. Okay, so here we have a data set. So this particular data set, what they did here was they looked at, let's scroll down, 77 different breakfast cereals. And you might say, well, wait, it goes to 78. Well, it does go to 78, but the first entry here is the kind of the title. And I should have put this, it's sugar in grams. So the first one is the title. So when we scroll down, it goes all the way to 78, but we actually only have 77 data values in there. So our data is in A2 all the way to A78. Okay. So 77 breakfast cereals were looked at, different breakfast cereals, and the number of grams of sugar in a serving, I believe, was noted. So this is all that data, right? It doesn't tell us which cereals, though actually I could go back to the original data and look at that, but we're not going to worry about it. We're just looking, we just are wondering, like, out of these 78 very popular breakfast cereals, what's the distribution of how many grams of sugar per serving they have, right? So some cereal had 6 grams. One had 8. Here was one with 14, right? So this varies. So you have all these data, and these are rounded to the nearest whole number. So if it had like 6.3 grams, it's marked 6. Okay, so what we want to do with this data is we want to make a grouped frequency table. Now it's grouped frequency table because, first of all, we've got 78 things, numbers in our list, and some of them repeat, right? Like there's going to be more than one cereal that has 8 grams of sugar in it, probably a lot, right? And so we want to make groups, right? And we get to decide how big those groups are. There's freedom in that. And then we want to make a little table that shows the groups. And then once we have that information, we can build a histogram. And I'm going to do it all in Excel. I think that's the easiest way to do it. Okay. So let's get moving. Okay, so the first thing we want to do is decide on the number of bars. Rule of thumb is that you want to use between 5 and 15 bars in a histogram. I always think the more bars, the better, typically, but I mean, not to an extreme. So somewhere between 5 and 10 is 5 and 15 is a rule of thumb. Right between 5 and 15 is 10. So I always start with 10. And actually, 10 usually turns out to be a pretty good number. In all the examples that I've been doing, I feel like I never have to go away from 10. Now, if you make a histogram and you're like, that does not look good, you might want to increase, right, or decrease the number of bars. But I find 10 is usually pretty good, especially for what we're doing at this level. So here I have a spot on my sheet for number of classes. And that is if I do everything else in terms of that number of classes, then sometimes it makes it easier to, if you want to like recalculate stuff, if I just change that number, then those other things will recalculate automatically. Okay, so I'm going to put 10 here. Okay, so now what we want is we have all this data, right? What we had 78, 77 values. And we want to divide them up into 10 bins, basically 10 groups. All right, so an easy way to do that is to find out, right, like, we look at, okay, well, we have, this many numbers, right? Look at the range of the numbers. So what's the smallest number? What's the largest number? Find out, right, like how far that distance is. That's called the range. And then divide that by 10 to see basically how much will fit in each group. Okay, so this is how you can do that. Here's the data. Notice this data is not ordered. So one way you could find the smallest, now I have written here smallest class limit. That's going to be the small, okay, so let me talk about that before. So I'm going to put over here, like I'm going to put the minimum of the data set and the maximum of the data set. So I want to know what's my smallest number and what's my largest number. Okay, yes, because that's a little different than this. So I'm actually going to just rearrange stuff here for a minute. Did you know that if you select stuff and then wait until your cursor is this four-sided black arrow and you can drag whole thing of cells. So I'm going to just do that because I might want to put something else over there. Okay, there we go. And then I'm actually going to move these back up here. Okay. So before that, there's a couple ways to find the minimum. You can use a function in Excel called min. So if you put equals min, you can see that min comes up and returns the smallest number. I know this is kind of small, but some things in Excel, like even when I zoom in, they don't zoom in. All right, so let me try this again. Equals min. Yes, that's what I want. Okay, so then you just have to say, well, the minimum of what? Well, I want the minimum of this set of data. So there's a couple ways you can do it. My default is to just go and use my mouse and go grab the first one and then drag all the way down to the bottom. Move, move, move. Right. And then there you go. Now this is kind of a long set, so got to scroll back up. And then don't forget to close your parentheses and hit enter, and there you go. And this is a very interesting thing. It's telling me the minimum of this data set is -1. But wait a minute, what is this data measuring? It's measuring grams of sugar in a serving of cereal. How can there be negative sugar in a cereal? It makes no sense, right? So this has got to be an error. If you actually come back here, this is the original data set. That -1 is right here for Quaker oatmeal. Now, oatmeal might not have any added sugar, right? And I think that's what this is counting, actually, like added sugar, because everything has a little bit of sugar in it. So I feel like that can't possibly be true. So it wouldn't make any sense to use a -1. So I'm actually going to go here and I'm going to change that -1 and I'm going to make it a 0. And just for fun, I'm going to highlight that cell just to remind myself that that value, like there was a weird thing going on there, but it makes way more sense to have 0 than it does to have -1. Now, I also was thinking to myself, well, maybe whoever was inputting this data just typed the negative by mistake. Maybe it's supposed to be 1. But then I was thinking, well, oatmeal, like just plain oatmeal, doesn't usually have any added sugar unless you're getting those packets, those that are flavored. So it makes more sense for it to be 0. So I'm just going to leave it as 0. Okay. So really, and notice how, because I had used the function and I said min, right? It changed to 0 when I changed that value to 0. Okay. And then you can do the same with max. You do equals max, right? And you can see here it says returns the largest value, so it tells you what the function is doing. So if you're, if you start typing and you see a description that doesn't match what you want to do, then don't use that function. But this one is exactly what I want to do. And instead of selecting and scrolling or dragging all the way down, you could just type in the range. So my data starts in A2 and it goes to A78, right? Now notice there's a colon between those two. That's how Excel works. Okay, so the minimum value is 0 grams of sugar. The maximum value is 15 grams of sugar. Another way to do that would be to sort the data set. So if you click on any value in your list and then go up to, let's see, where is it? I have my screen is sort of condensed, so some of these things are hidden. I think it's editing, sort. Now, if I were full screen, I would be able to see that. But so then I want to sort and I want to go smallest to largest. Then it sorts everything. And I can see that the first number is going to be the smallest. So the minimum is 0. And then if you scroll down to the bottom, you see the max is 15. So that's another way to find the min and the max. But okay, so now at least we know that this data set ranges over 16 numbers, 0 to 15. That's a total of 16. Okay. Now, what we want to do is take care of that issue. Because say we decide to have a class width of, I don't know, say 5. Not that that's going to be it, but if we're going to go from, say, 0 to 5, right? I guess in this case, it doesn't really matter because you can't be between 5 and 6, right? So that's nice because they're whole numbers. However, if I use a class width of 0 to 5, right, the next bar, the first bar is going to end at 5. The next bar is going to start at 5. Where are the 5s? How do we know where the 5s are? Are the 5s going to be in the first bar or are they going to be in the second bar? So to take care of that, what I like to do is on the histogram, use a numbering system that it has one more decimal place than the actual data values, right? So my data values are all whole numbers. So they have no decimals, right? So I am actually going to, instead of using whole numbers as my boundaries, I'm going to use numbers with one decimal place. So for instance, my largest value is 15. So I'm going to put 15.5 as my largest class limit. So my last bar is actually going to go up to 15.5. And what that does is, well, we'll see what that does in a minute, right? Now I did that one first because it's easier because this data has 0 as its smallest number. I want to go a little bit less than the smallest number. So a little bit less than 0 is a negative number. So that's kind of weird. But in this case, because it's a negative number, that's okay. So I am going to put negative 0.5. Oh, I did my point negative backwards. Negative 0.5. That's better. Now, why am I using 0.5? 0.5 is just a really easy decimal to do, right? I'm just doing like 1/2 before the smallest and after the largest. And now what this does is that means that the first class, the first bin, is going to start at negative 1/2 and go up to something like, I don't know, say 3.5. And that makes it very clear what values in our data set are in that bin because there are no data values of 3.5, right? If it's between negative 0.5 and 3.5, you know that we're only going to have 0s through 3s. Does that make sense? I'll try to remember to point that out later when we make a histogram. Okay, so when I make my histogram, I'm going to have on the left-hand side, the smallest, the first bar is going to start at negative 0.5, and the last bar is going to end at 15.5. Okay, so these are the smallest and largest, and this CL stands for class limit. That's what that means. Now I'm going to do some calculations to estimate the class width. So CW is class width. So what I'm going to do is, remember in Excel, if you put equals, that tells Excel that you're going to either use a function or do some calculating. In this case, I'm going to do calculating. So I'm going to do larger, why does largers have an S? There should not be an S there. Anyways, the larger class limit minus the smaller class limit Oh, and then I want to divide that by 10 because that's the number of classes, but I can't just do divide by 10 because Excel knows the order of operations. And if I put that, Excel is going to take the smaller class limit, divide it by 10, and then subtract that from the larger class limit. So to fix that, what we got to do is, well, not do that. We got to edit it. We have to put parentheses around this difference. Do you see what I'm doing? You can see it up here. I had to put parentheses, and this is one of those things, this bar, I can't increase the size of. If I go and zoom in, all of this stuff gets bigger, but this bar doesn't. It's very annoying. What is this? Oh, that's fun. Okay, so if you notice here, though, you can see it a little bit better. I'm putting in, yeah, I can zoom in there. Oh, I guess I can't if I'm here. So now it went away. There you go. You can see that I put parentheses around the D8 minus D7. So I'm referencing what's in these cells. Take this cell minus this cell. And you put parentheses around that so Excel knows to do that subtraction first and then divide by 10. So it's taking the whole range of the data and dividing it up into 10 pieces. All right, so that's saying that the estimated class width is about 1.6. Now, what you want to do then is round that. And typically we round up. So I'm going to say, okay, let's try a class width of 2. Now, of course, if we do it with 2 and we don't like it, we might have to redo it with a different number. If we think there should be not as many, we go up. If we want there to be more, we go down. We don't have much down. If we go down, it's class width of 1, and then you've just got your list. But between 0 and 15, you can go 2 times about 7 times. So that'll probably give us around 7 classes, which is okay. It's okay that we don't get exactly 10 because we're going to get 10 or less because we've rounded our class width up from what it, 1.6 would give us exactly 10. We round up, we might have less than 10. All right, so what do we do now? So now we know we want our class widths to be 2 wide. Okay, so now I'm going to make a list. I'm going to come over here. And I'm going to say, okay, I'm going to define my classes. I'm going to put the lower limit in this column. And I'm going to put the upper limit in this column. And I said, this video is detailed, so it might be kind of long. So you can skip forward and, if it's whatever you don't understand, if I'm talking, you're like, just don't listen for a minute. But it's quite detailed. Okay. So the lower limit, so for the first bar, we want our smallest class limit. So I'm just going to copy this value and put it right here. Okay. And then our class width is 2. So we want that class, right, to start at negative 0.5 and then add 2 later. So just add 2 to that. So that's going to be 1.5. Now, if you were confused how I got that, you could actually do the math. You could do equals and click on that value and then add the 2, there's our class limit, and it'll do it for you. Okay. So now we are going to use that same number as the lower limit for the next class. And so actually, so like every upper limit for the previous class is going to be the lower limit for the next class, right? So if we add 2 to 1.5, we get 3.5. Okay. And then 3.5 is going to be also here. So what I tend to do is I don't do the upper limits. I do all of the lower limits because these numbers are also going to appear here. So let's see. So 3.5 plus 2 is, this is a nice one. I don't have to, I can just clearly see it because we're adding 2. And then 7.5, and then 9.5, and then 11.5 plus 2 is not 12, but 13.5. And then 15.5. All right, there we go. So how many classes did we end up with? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. Well, not too bad. All right, so this class, the 3.5, the lower limit, its upper limit is going to be 5.5. So what I like to do, this is a shortcut that I realized you could do after doing this the long way. If you just take all of these, you could put them right here, and they match up. And then actually, I don't need this one because that's actually the last bar. So we're going to have a histogram like we saw, right? The first bar is going to contain all the values that are between, right? Basically 1 or 0 or 1. right? Because look what happens, right? We don't have any values that are decimals. So if you're greater than negative 0.5, but less than 1.5, you're either 0 or 1. So this class is going to contain all the zeros and ones. This class only is going to contain the 2s and the 3s. And this one's going to contain the 4s and the 5s and the 6s, and so on. Again, the reason I'm using decimals here is so that we don't have to worry about the boundary. Like if we actually went from 0 to 1 and then from 1 to 2, which class do we put the ones? Is it in the first one or the second one? Now we don't have to worry about that because it is clear that anything with 1 gram of sugar goes in this first class, and anything with 2 grams goes in this class. Does that make sense? Hopefully it makes sense. Okay. So these are our classes, right? We've got and each of them is width 2, right? And so they each are going to have, right, however many. So now we want to get the frequency. So let me make a frequency, make a column for frequency here. Now there's a couple ways to do this. We can do it manually, which is not so bad with a data set like this. Or we can do it with an Excel function, which is slightly complicated, but once you know what it is, it's not that bad. So first of all, right, what do we want? Well, we want the frequency is how many of the numbers in our list, right? How many of our data values fall in this range, right? So like we said before, if you're bigger than negative 0.5, but less than 1.5, you're either 0 or 1. So we can come over here and just count, right? How many zeros and ones do we have? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9, oops, not 0, 9 numbers in that first class, okay? Second one goes from 1.5 to 3. So that means 2 or 3, since our data values are whole numbers, right? The whole numbers in between 1.5 and 3.5 are 2 and 3. So how many 2s and 3s we got? Well, we got a lot. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. We've got 16. All right, so that's one way. You could do it that way and just manually count. And you can see like that actually wouldn't take very long. But if you want to be fancy, there is a function in Excel and it's called count ifs. So that's, I'll show you. You put equals and you start doing COUNT IF, and then you can see there's 2. So there's a count if and there's a count ifs. It's funny because count ifs is like plural, right? Count if you can only give one condition, count ifs you can give more than one condition, right? And I'm going to use count ifs because what I want it to do is I want it to look at this list and count all the numbers that are bigger than 3.5 but less than 5.5. So it's going to look confusing, but it's actually not once you understand it, right? So what does it do? What is confusing though is how Excel is trying to guide you, like, like what do you need to put in there? Like criteria range. That didn't make any sense to me. What it's saying is it just wants what range is it going to look at? Okay, so this is where we want it to tell where our data is. So our data is in A2 to A78. So I notice how it like highlights it, so that's where our data is. And then I'm going to put a comma. Okay, because notice here how it says criteria range 1, comma. And then you have to put the criteria. Now the problem is how do you do that? What if I click on this? Like, is that like a link? Like what happens? I feel like, look, it's like it should be linked, but it's not. I don't know what that means. So I had to look this up. Took me a long time, but now I'm sharing all that effort with you. So what you want to do is put here is like, okay, what is it looking at? What's the first criteria? Well, I want whatever it counts to be bigger than 3.5. Right. And so I'm going to tell it that. I'm going to say, look at numbers that are bigger than 3.5. How do you do that? Well, for some reason, you have to put it in quotes. Don't ask me why. Somebody programmed Excel a long time ago. It was not me. You got to put it in quotes. And then I'm going to put greater than, the greater than symbol, which is it's the greater than is above the period on your keyboard. And then for some reason, you have to put greater than or equal. I tried it once with just greater than, and it didn't work. So greater than or equal to, so greater than equal, close your parentheses. So that's saying that's the relationship I'm looking for. But then greater than or equal to what? Well, 3.5. So you would think you could just put 3.5, but no, for some, see, it says that's not right. For some reason, you have to put the Is it the and symbol? You have to put the and symbol on. Why I have a single quote when there should be a double. Why can't I put a double quote? There it is. Let me double check over here. I have this written down. Yeah, you got to put an and symbol, and I don't know why. So hold on. We're not done yet. I have not been able to find anything online about people explaining what that and sign does. I just know it has to be there or it won't work. So you give it the range, right? You want to look, there's my data, and then look for any number greater than or equal to 3.5. Okay. But I don't want it to look for anything greater than 3.5. I want it to stop looking at 5.5. So what I have to do now is I have to do this all again. So I have to tell it again where the data is for some reason. So again, look at A2 all the way up to A78, put a comma, and say, okay, now I want it to look at anything that's less than or equal to 5.5. So do the quotes again, less than equal to, end quote, and sign for some reason, and 5.5. Okay. Now that's good. If you click on that, notice that it's brought 6 back. So it's saying there are 6 things between 3.5 and 5.5. Let's just double check for fun. So what numbers are between 3.5 and 5.5 in our set? That would be 4 and 5. So how many? Ooh, that's a lot of 4s and 5s. So how many 4s and 5s are there? It says there's 6. Let's see. 1, 2, 3, 4, 5, 6. Yay. Okay. Now, what I want to be able to do is drag this down and it'll automatically copy that formula for everyone else. But notice if I do that right now, it's not doing that right. It's not the case that there are 6 for all of these. So what went wrong? Well, let me show you. If you drag that down, if you look at the formula in here, notice that it's changed the range for the data. Now it's looking at A3 to A79, so it shifted it down. We don't want that. Also, it still has the values 3, 5, and 5, 5. So there's a couple things we have to do. One of them is we have to make sure it doesn't shift where the data is. So how do we do that? So let's stop. Get away. So I'm going to erase that. Okay, so let's go back here to our original formula. How do you make Excel not shift part of your formula? You do that using dollar signs. Why dollar signs? I don't know. So if you put a dollar sign in front of the row, no, that's the column, and a dollar sign in front of the dollar sign, in front of the, so column and row, right? It fixes it. It tells Excel, don't shift those. Those are like, it's like, what do they say? It's an absolute reference. Never will that reference change. So we want to go through and put dollar signs in front of all the rows and columns. Right? And so that way those will be fixed. Notice it doesn't change this formula, but now if we drag it down, it won't change those. So notice how in this one, it's still A2 to A78, which is what we want. However, it's still looking at the wrong numbers. So one way to fix that would be to go here and instead of typing in the numbers we want, reference the cell the number is in. So what do I mean by that? Okay, I mean that up here, I'm up here now. Instead of typing in 3.5, I'm going to say I'm going to do and then I'm going to click. And notice how it puts F5 there. So instead of having the number 3.5, it references what's in the cell F5, which is indeed 3.5. And I'm doing the same thing over here. Instead of typing in 5.5, I'm going to click in the cell that I want, and it inputs automatically G5. So now it's saying, okay, count all the numbers in this list that are greater than or equal to whatever is in F5, and same list, less than or equal to whatever is in G5. All right, so that's nice. Now what that does for us is when we drag down, bam, let's take a look at what's in this one. It did shift that, right? So now it's looking at F6, which is 5.5, and F7, so it does that automatically. Very nice. So Excel sometimes takes a little bit of effort up front, but once you put that initial effort in, it does a lot of things automatically, and it's really nice. Okay, so these are our frequencies. I like to double check. We're going to see if these frequencies add up to 77 because they should if we've made no errors. So I'll give you another pro tip. If you choose this cell right here underneath this little list, if you click Alt plus, Excel knows oh, you want me to add the numbers that are above this cell, and yes, indeed, that's what we want. Right? If you didn't know that, you could just start typing equals, and it's sum, not add. If you type add, that goes to address, so that doesn't work. So when you add stuff together, you get a sum. So you could just type that, and then you'd have to give it your where, not a, it's like, where are the numbers you want to add? They're right here. But I have recently learned, and I think that was just a couple weeks ago, that if you do Alt equals, it tries to guess what you want to add, and it's usually right. All right, and there we go. 77 is exactly how many data values we have. So that means our frequency table is probably good, right? We want to add all the frequencies together. It should be how many values we've got. All right. Now, if you want to do relative frequency, let's put that over here. Because in some of your, I think, assignments, you might have to do that. So remember, relative frequency is just the proportion of the total that this value represents. Right? So we have 77 total. If we have 9 out of those 77, what percent of our values do we have? So you can just do that by doing equals and taking this number and dividing it by this number. And there you go. So that's another reason to have the total here, because we can use that. I mean, you could just put divide by 77 every time, but you don't have to. Now, here is another issue. If we drag this down now, we're probably going to get something weird going on, and you can see yes, because it doesn't know what to do. It's looking at H4 and trying to divide by H12, and there's nothing there. And so it's like, what? Trying to divide by 0, that's illegal. So what we didn't do is we didn't fix this cell. So if we go back here in our formula, and instead of H11, we'll put $H $11, and that will fix that reference. And so it will always look to divide by 77 as opposed to something else. And now that's a lot of decimal places. I know you don't really want that many. So let's see, no, it's the wrong way. I always go the wrong way. We do 2. Now, if you want the relative frequency as a decimal, if you want it as a percentage, you could change those to percentage, right? And then but right, percentage or not. Wait, how do I get back to a decimal? Want to do just number? Yeah. And then maybe 3 decimal places. Okay, and then of course, if you add all these together, what should you get? If you add all the relative frequencies together, right? So we added the frequencies and we got how many data values we have. If we add the relative frequencies, right, then we're adding the portions of the whole of each one. So what should that equal? Do you remember? Let's see if you can remember. Yes, indeed, it should give us 1, right? Because once you've used them all, you've got 100% of everything. So the relative frequency should add to 1 or 100%, which are the same. Okay, so that's how to do the group frequency table on Excel. Hopefully that made sense. Now I'm actually going to stop this video here, and I will make a separate, shorter video about how to make the histogram. Okay, see you later.